Welcome to Spring LIB.
Okay, so this question is asking us to find the acceleration of a box that compresses a spring. So we have our wall, and we have a spring attached to the wall, and the spring gets compressed by a box. Okay, so here's a little diagram, and on this diagram we can write our constants. So we have our K, the spring constant, is 85 newtons per meter. We have the mass of the box is 1.5 kilograms. And this mass gets displaced 6.5 centimeters, which is equal to 0.065 meters. And we're asked to find how fast does the box accelerate. So for this problem, we only actually need two equations. We need Hooke's law, Hooke, which deals with springs, and we need Newton's second law. Just the N is short for Newton. So Hooke's law is the force on a spring is equal to negative K, the spring constant, times X, the displacement from equilibrium. And Newton's second law is force equals mass times acceleration. So very clearly we can combine these two to give us the equation that we need, which is ma equals negative kx. So even shorter, or just getting all of our constants on, or all of our known things on one side, we have acceleration is equal to negative spring constant times the displacement divided by the mass. So when we substitute our knowns into that, we get acceleration equals negative 85 times 0.065 all over 1.5. And that is going to be equal to negative 3.68 meters per second squared. And just for clarity, this negative sign is referring to the direction relative to the displacement. So we have our equilibrium right here, and we have our displacement here. So if it's displaced this way, along the red arrow, it's going to have a force countering that. And keeping with this color scheme, the acceleration is going to follow the force. So that's all that means. We have our final answer is 3.68 meters per second squared. Meters per second squared along the direction of the blue arrow. Okay, that's it. Thank you.